Hi, welcome back. I'm Helen and we're doing life sciences today, and of course we're looking at the scientific method. Before the break we looked at observations and questions, and now we have to start looking at this thing called a hypothesis. Well, we've gathered some information. We know that grass doesn't just turn yellow for no reason. We've done some research into what turns grass green, what turns grass yellow. You've possibly done some research into why sugar dissolves in water, and does temperature actually affect the way that sugar dissolves in water. And so you've got a little bit of research, and now you're ready to get to the next step in the scientific method, which is making a hypothesis. Now, some people call a hypothesis a testable guess. I think it's more than just a guess. It would be a guess if you just sucked the information out of the air and made any old guess. But remember that we have done this amount of research here. And when we've done the research, that means that we're going to be approaching our hypothesis making from a position of knowledge. We know something, and so therefore we're going to be able to make this hypothesis with some kind of foundation behind it. It's not just a guess. But the two important things about the hypothesis. First of all, it's a statement. It's never a question. We've already asked the question, and the hypothesis then is a statement as a possible answer to that question. And the second thing that's very important about a hypothesis is you must be able to test it. You can't have a hypothesis that it's impossible to actually test. Those are the important things you must remember about a hypothesis. And so if we look at our grass, for example, that has been growing, and now that there's yellow grass underneath the brick, a hypothesis could be that patch of grass needs sunlight in order to be green. Or if you were thinking about your coffee investigation, you could say that sugar dissolves better or faster or more effectively in hot water than it does in cool water. That is what a hypothesis is. It's a statement that you are making that is testable and that answers your question. But we don't know if your hypothesis is the correct answer to that question, and so therefore we need to go on and design some sort of investigation, a test for that hypothesis. And we're going to start designing an experiment. People think that experimental design, well, it doesn't matter what you do, but your whole investigation actually lies on how well you designed that experiment. And there's lots of things, of course, that we must look at when we're looking at experimental design. The first thing is, of course, your experiment must test the hypothesis. Lots of times I look at students' work and I say to them, but this is a very exciting experiment. But what was your original question and what was your hypothesis? The investigation must test what your hypothesis stated. And the next vitally important thing is that it must be a fair test. Now, can you imagine if your teacher said to you, okay, we're going to run a race, but these people, they must run the race with their shoes on and their school bags on their back, and they must just have eaten lunch. And you know what? I'm going to let the girls start over there closer to the end, and they don't have to run so fast. Is that a fair race? Well, of course not, because in a race, all things have to be equal and fair. In the same way, your investigation has to be fair. All of the factors that possibly could change and influence the outcome must be kept constant. And so you have to identify all of those variables that could possibly affect the outcome, and they've got to be kept constant, and your one variable can be allowed will change, and that is the variable that you are testing. Very often in matric exam papers, even in your grade 10 and 11 exam papers, your teacher is going to give you an investigation and say, what's wrong with this investigation? Why is this investigation not valid or reliable? And look and see whether it's a fair test. Are all the variables being kept constant? Because very often an unfair test will result when the variables are not kept constant. You're going to write out your design in point form, and you obviously are going to list all the equipment that you need in order to accomplish the outcome. And once you've designed the experiment, well, you are ready to go on to conducting that experiment. And so you've got to follow the steps that you spoke about in your method. You've got to keep detailed records of your results, and you've got to repeat that experiment, not once or twice, but a couple of times, so that you can make sure that those results that you have got are not just once off and a mistake or a fluke. You've got to actually see that they actually can be repeated, that this is reliable, because every time you do this experiment, you get the same outcome. You get the same results coming out of this experiment. And conducting the experiment can take you a long time. It's not something that's going to happen very quickly. You've got to really persevere, work through it, test it, repeat it, and finally you're at the point where you can present your results and you've accomplished going through the experiment, following all the different steps in the method. And when we come back after the break, we're going to look at results.